Okay. There's a simple answer, which is a sort of joke answer, I suppose, is that we only ever do surgery in mathematics to kill, never to save or heal. So, what do I mean by to kill? So, an end surgery on M, removing this framed embedding Sn across Dn minus N, which I'll call G, is said to kill the element. So I'm going to call the core of this embedding X. And this is in IM of M. And at the same time, what I've been calling the dual surgery, so going from M prime to M instead, the dual M minus M minus 1 surgery kills the dual framed embedding G prime. Well, it kills the core of that. Which I call X prime. Okay, so I should probably reserve a whole board for the next composition. So we have an end surgery as above.
So you colour coding X is the red thing.
X was, so the red thing was the attaching sphere, and the blue, which is now purple because I lost the blue, was the core.
Okay.
So it's the blue one from before.
Okay.
If you remember, we had the handle, the attaching sphere, there's the core, and then we thickened it up. Oh, hold on. No, I do mean the red thing. I do mean the red thing. You're right. Yeah, it's the red thing. Sorry. The word core is used for two different things, possibly a bit confusing me here.
Yes,
This is the core of the framed embedding, but there's also a core of the handle, which is the blue one. As above. So this is the effect on commodity groups. Pi I of the cobordism is equal to, we have two cases, either the same as the end n, if I is less than n, or in dimension n, we've killed off the normal subgroup generated by x. So this is for I equal to n. And the same goes for the dual surgery. So IIW is unchanged, same as M prime, if I is now less than this dual index, M minus N minus 1, and we've killed off X prime in dimension N minus N minus 1. So there's also an effect on homology, which I'm not going to mention here because I'm not going to use in this talk. So I'll just say for homology, Cn get Andrew's proposition, what was it, 4.19 in Andrew's book. Okay, so Mark. So in particular, what we want to do is we would like to do surgery to kill off pi I up to a certain dimension, or as much as possible. So when can we do this? So we would like to go from m to m prime and decrease the size of the homotopy groups. So what we would like is, in the case that I equals m and I is less than n minus 1, we get this and this holding. So we get that pi I of m prime is the same as pi I of w is the same as pi I, so these are all n's, sorry, because I equals n, pi n equals pi n of m with x killed. So if these conditions hold, we can kill off all these classes. So when is this? This is if and only if so n is less than this, so m is greater than 2n plus 1. So we can do this up to the, so if m is say 2m plus 2 dimensional, we can do this up to half the dimension minus 1. So we can kill up to m over 2 minus 1, I think, the ceiling of that. But if this is not satisfied, we can't necessarily get this to work. So one or two more examples, and then we'll have a break. Okay, so it's probably worth doing the sphere example. Think of now a 2n dimensional manifold M, and we'll write this as M connect sum a 2n sphere, and what we're going to do is we're going to do surgery on this sphere. We'll do an n surgery. So now n is half the dimension of the manifold, so it's certainly not in that range. As follows. So we can decompose S2n as Sn cross Dn union, I think this is right, Dn plus 1 cross Sn minus 1. So for example, in the case that we just have the 2 sphere, what we've done is we've taken framed embedding of the equator, which is an S1 cross D1. So we've got this part, and then we've also got framed embedding of the poles S0 cross D2. Yes. And this works in general for S2n. And what we do is we do surgery on the first part. So M prime is, again, M connect sum, the effect of surgery. So now we've got Dn plus 1 cross Sn minus 1 these dn's fit together, the dn plus 1s fit together to make a sphere. So this is Sn plus 1 cross Sn minus 1. Okay. Now the point here is that we've done an n surgery, but we've affected pi n minus 1 because of this factor here. So n surgery on a 2n dimensional manifold can change pi n minus 1. So in particular here we've just got pi n minus 1 of m prime, I'm just going to call it, is pi n minus 1 of m with an extra z. But this doesn't always happen. You can sometimes do a surgery, n surgery on a 2n dimensional manifold and kill off pi n. So this will be example 2. Well, we sort of do a similar thing in reverse. We take the framed embedding Sn cross dn into Sn cross itself, and then what we get from m prime is, so we do surgery on this bit, replace that with dn plus 1 plus Sn minus 1 union this. Now, if we carefully think about what this is, in the same way we were before, we note that this is just S2n. And so in particular now, pi n minus 1 hasn't changed. It's still 0. Okay, so that's more or less all I want to say about surgeries and handles for the time being. So we can take a 5 to 10 minute break and then I'll continue